All right, everybody. Next review topic is on multiplying polynomials. So, or before we do that, let's talk about a couple of things that we have already learned about. First is adding and subtracting like terms. So, if you remember, like terms are the same variable and the same exponent, and when you add or subtract them, then you're just going to add or subtract the numbers in front of your like terms. So if you have 3x plus 5x, that makes 8x because 3 plus 5 makes 8. You cannot add 3x and x squared because they have different exponents. And if I had x squared minus 2x squared, remember there's that imaginary 1 in the front, and that gives us negative 1x squared. So in addition to that, adding and subtracting like terms, let's talk about distributive property. So we already know how to do distributive property, where we take some number on the outside and we multiply it by our numbers on the inside. So 3 times 5 made 15. 3 times 2 makes negative 6, so that ends up being 15x minus 6. Also, way back when you did exponents, you added your exponents together. So if I have x to the first times x to the first, that's 1 plus 1, and that makes x squared. Or if I had 3x times 5x squared, that would be 3 times 5, and then x to the first from this first group, and x squared from that second group. So we're going to add those two exponents together, and I get 15x cubed. Okay? So what we're really going to do is take all of those things that we've already learned and we're going to put it all together. And we're going to say, okay, can you take 3x squared and multiply it by a group of items? So we're going to use our distributive property and we're going to add our exponents together. So 3 times 5 makes 15, x squared, and x to the third makes x to the fifth. 3x squared times negative 4 is going to give me negative 12x squared, and that gives me a total of 15x to the fifth minus 12x squared. So if you can do this little bubble right here with the little cloud thing around it, that will be basically all you need to do for multiplying polynomials. You can do distributive property over and over and over again as many times as you need to multiply any sets of polynomials. So alongside here, in addition to my video, there's a whole bunch of extra videos that you can look at if you want. But let's go ahead and jump into our notes. So first, if we take a look at multiplying polynomials, again, we already talked about this. Basically, all you need are two things. You need your distributive property and you need your exponent rule for multiplying bases. So if you have any base to a power times that same base to a power, you're going to add your two powers together. That's really the only thing you need. That means you can multiply any sets of polynomials times polynomials. So what are our different kinds of sets? Well, we can have a monomial times a binomial times a polynomial times a binomial times a polynomial times a polynomial. And for all of those, you're basically just going to go through and do distributive property a whole bunch of times for each of those things. Okay, so let's take a look at a couple of examples. So let's start here with my monomial times a binomial. And this is the distributive property one we just did. So if I do 3x squared times 5x to the third, I get 3 times 5 to make 15, x squared times x to the third to make x to the fifth. 3x squared times negative 4, that gives me negative 12, and then there's only one x squared there. So my total answer here is 15x to the fifth minus 12x squared. Okay? You can do that for any set of polynomials. So if I have one term times three terms, one term times seven terms, if I really wanted to, I could just keep distributing and distributing and distributing and adding all of those exponents together. It might be helpful to you when you're doing this to remind yourself that if it just says x, that's really x to the first power. And you might want to write your 1 there so that you remember to add that 1 to whatever value you have. So that kind of reminds me at the beginning here that I have 1 plus 2 to make x to the third when I do that first distributive property. Okay? Now, when you come to two binomials, you can think about it as two distributive property problems. So you could think about it as taking this first group and chopping it in half and making that this first term distributed to the whole second parentheses and the second term distributed to the whole second parentheses. So 3x times 2x plus 5 and negative 7 times 2x plus 5. And then you can do your distributive property 2 times. So I have my first distributive property, 6x squared plus 15x. And then over here, my second distributive property is negative 14x minus 35. And then the only thing you have to do is remember to combine any like terms when you do multiple sets of multiplying. So once you've moved past one term times something, if you're doing multiple terms times your product, you need to make sure that you combine your like terms at the bottom. So in this case, we're going to do 15x and negative 14x, and that gives me positive 1x. So I have 6x squared minus x minus 35. Okay. Now, if you need more help on multiplying polynomials, I would check out both of these videos right here. And they will also talk about the box method, which could be helpful for you in any of those. So multiplying binomials at the top, and then doing the box method if that's something that interests you. All right, let's talk about some shortcuts. So we know this acronym that maybe you have heard before, and that's foiling. And basically, foiling is just a mnemonic device to help you remember how to do that distributive property in the proper order. So if you think about FOIL, remember that means first, outside, inside, last. That's just a distributive property problem, but the first, outside, inside, last tells you what order to do the multiplying. So you can go through and see how to FOIL. There, like I mentioned in the video, is also the box method if you're interested in that, and that really just helps you keep yourself organized. And then there's also that horizontal method that if you remember how to multiply multiple digit numbers in regular multiplication, so way back in like 6th grade, then you can also use that for polynomials as well. You do not have to use any of these methods specifically. So whatever method works for you is what I'm going to ask you to use. I do not care what method you use. Just know how to multiply those polynomials. So go through the videos, find what works for you, see which one is best for you. Okay? All right. Last thing I want to talk about is those special cases. So if you remember, special cases are where your binomial, that means your two terms, has the same two terms in it. And those come in two different forms. So first, you could have the same two terms squared. So you might have two numbers added together, squared, or two numbers subtracted and then squared. So for example, you might have x plus 3 squared or y minus 7 squared. Those are both special because they have the little squares in them. Over here, the difference of two squares is when you have the same two terms, but one has a plus and one has a minus. So if I have x plus 3 and x minus 3, they both have an x, they both have a 3, but they have opposite signs. So those are all special cases. Now you can, if you want, go through and FOIL them all you want. You do not have to remember all the special tricks that I'm about to talk about. You can FOIL all you want. But it might be helpful or time saving if you can remember the little special tricks. So what are the special tricks? If you have something something squared, basically what happens is you're going to take the first number squared, the last number squared, and in the middle you're going to do 2 times the first number times the last number. Same thing with minus, first number squared, last number squared, but this time it's minus 2, first number times last number. So that's what it looks like down here. If I have 2x minus 5, then I can use the shortcut where my first term is 2x and my second term is negative 5 and do 2x squared minus 2 times 2x times 5 and then plus negative 5 squared. And that gives me a total of 4x squared minus 20x minus 25. Again, you can use the shortcut if you want, but you can also just FOIL if you wanted to. Over here for difference of squares, the whole idea is that those middle terms are going to cancel out because you have 1 plus and 1 minus squared. So this ends up just being the first thing squared minus the second thing squared. So if I have 3x minus 4 and 3x plus 4, my first term is 3x, my second term is 4. So then that gives me 3x squared and 4 squared. That's 9x squared minus 16. So again, if you want to do special cases, that would be great, and I think it would save you some time, but you certainly can just FOIL all of those things if you want to. All right, there's a couple of ways to practice here. So first, the Desmos practice. Remember, this is optional. It's just there if you want to practice. Basically, it gives you two polynomials to multiply. You type in the answer, and if it matches up with the graph that's already there, then you know you multiplied right. Not required, just optional. Same thing with the regular practice down here. There's all these different kinds of multiplying. Oops, sorry. And you can go through and check the answers at the end. All of that is optional. It's just for you to practice if you need it. If you have any questions, we have our virtual office hours on Wednesday. So feel free to pop into the Zoom chat on Wednesday if you have questions and you want to talk about multiplying polynomials. All right, good luck.